Hello everyone. So we are going to start the integration by parts, and this is NCERT exercise 7.6. So we will solve the question number 11 onward. So the question number 11 here we have given integrate x cos inverse x into dx by under root of 1 minus x square. So we are going to apply first substitutions here. That means we are going to assume that this cos inverse x is equal to what? So this is equal to, we can assume this is t. So derivative of this cos inverse x will be 1 by under root of 1 minus x square into dx. Minus sign I'm writing this side because derivative is minus 1 upon under root of 1 minus x square. So instead of writing this minus on the LHS side, I have written on the RHS. Now from these substitutions, we can write this is equal to, means cos t is equal to, or yes, cos t is equal to x. Now we can replace in integration. So it will become finally I is equal to integration of x is now cos t. X is cos t and cos inverse x is equal to t. So this is t and 1 upon under root of x square. 1 minus x square is minus 80. Now we have to integrate it. So minus sign outside and we are going to take the first sign. This is our first function and this is the second function according to the Eilert rule. So here we have to integrate the second function. So second function here is cos t. So we are writing cos t as it is and then minus integration inside here d dx of the first function. D actually d dt. So of the first function, that is t. And then integration of the second function. What is the second function here? So second function is cos t. So here we are writing cos t dt and then actually we should take bracket here also. So bracket close into dt and then one more bracket at last. So now we are getting here this minus will be as it is, this t will be as it is, integration of cos is sin t and minus integration here derivative of the t is 1 and integration of the cos is sin t into dt. All right, now here this minus as it is t sin t and integration of the sin t is minus cos t. So here it will become plus minus minus plus and cos t. And at last we are writing here plus c. Now we can replace our t. So instead of replacing t, we are replacing the cos t in the terms of x. What we can do here, cos t is equal to x. So from here, what we can say, if cos t is equal to x, that means sin t will be equal to sin t will be equal to under root of 1 minus x square from the first identities, sin square theta plus cos square theta. So we can write like this. So our final answer will be equal to what? Minus sign here and t means cos inverse x. So here we can write cos inverse x and this is sin t. Sin t means under root of 1 minus x square. 1 minus x square. Right? And here here also it will become minus now. So minus of cos t means x. So minus x and then here plus c. So this is the final answer. Right, now we are going to move on the second. That is the question number 12. What is question number 12 here? So question number 12 we have given I is equal to integration is from integration of x secant square x secant square x into dx. So here actually we have directly given the simplified form of the function only. That means we can say this is the first function and this is the second function. So easily we can apply the ByParts rule. So according to the ByParts here, this first function outside and we are taking the integration of the second function and second function is just secant square x into dx. All right, minus here integration derivative of the first function. So I am directly writing it will become 1. And here integration of the second functions, that means integration of the second function secant square x into dx. Correct. And actually here now we should take one bracket. So then after that also we need to take one dx. All right. Now x is as it is, and we know that integration of the secant square x is tan x. So it will become tan x. And here integration of the secant square is tan x and then dx. So now finally we can write x tan x, and from here, integration of the tan x is log secant square x, or we can say minus cosecant. So because of the minus, it will become plus, and minus of cos x and plus c. Right? So this is the answer of the question number 12. Right? It is easy. Now we'll move to the question number 13. So the question number 13 we have 13 integration. That means I, let I is equal to integration sign, and this is from, it is just tan inverse x. So how we can integrate it? We have to take or multiply here with the 1. Means here I am taking 1 because there will be no difference if you are multiplying. So now we have to decide first and second function. This is our first function. This is our second function. Now we have to apply the by parts. So if you are applying by parts, here it will become 1, or actually it is tan inverse x. So tan inverse x will be the first function. This is first function. It is not tan, right? And this is second function. So first function, that means tan inverse x will be out as it is. It is tan inverse x. And now integration of 1 into dx, and minus integration of bracket derivative of the tan x, that is d dx of tan inverse x, and then integration of the second function, that is 1 into dx, and then dx, right? So this tan inverse x as it is, and this will become x, and minus here integration of derivative of tan inverse x is 1 by 1 plus x square, 1 by 1 plus x square, and integration of x, 1 is x into dx, right? So for solving the second part, we can apply the substitution. So let's 1 plus x square is equal to, we are assuming this 1 plus x square part is equal to t. So let 1 plus x square is equal to t. So from here we will get 2x into dx is equal to dt. That means from here we can say x into dx is equal to 1 by 2 into dt. 1 by 2 dt. That means finally what we can write here? We can, for this part only, we can write here integration of 1 by 2 outside and dt and divided by t. Now it will become 1 by 2 log t. 1 by 2 log t. And now t we can replace, t is equal to 1 upon, that means it will become 1 by 2 log t means, log t means 1 plus x square. 1 plus x square. Here it is 1 and x square. So finally our answer will be I will be equal to x into tan inverse x, and then minus 1 by 2 log mod of 1 plus x square, and then here plus c. So this is question number 13. Now we'll move to the next question, that is question number 14. So what we have given here, question number 14, let I is equal to integration of what? So x and log x whole square into dx. So the according to the Eilert rule, here we can decide the first and second function. Eilert, that means log will come before the x a. So this is the second function. So here we are going to take the log x whole square outside of the integration. First function as it is integration of x into dx minus integration and inside, right, d dx of the first functions. That means d dx of x and then integration of log x. Sorry, here actually integration of derivative of the first function is the log x whole square. This is log x whole square. Here we have d dx of log x and this is whole square will come. And then integration of the second function that is x into dx. And then bracket close again one more dx. So now finally here this will be as it is log x and whole square and x integration is x square by 2 minus integration inside integration it will become 2 log x. Derivative of the log x whole square is 2 log x chain rule 1 by x. That means here only I am writing 1 by x. And the integration of x is x square by 2 and now here dx. So now we can see here this x square, this power will get cancelled out with this x and this 2 will get cancelled out with this 2. That means now we have just remaining terms here log x whole square and this x square by 2 minus integration of x and x log x dx. That means here again we can decide the first and second function for this part. Means we are going to solve this part first, this part. So how we can solve it? Here I let this is the first function and this is the second function. That means here our log x whole square will be as it is as well as this x square by 2 will be also as it is. Here we will write the first function that is log x as it is and integration of the second function will be x square by 2 minus inside integration derivative of x is 1, sorry, log x is 1 by x and x integration is x square by 2 into dx. All right, now here this x and x square will get cancelled out, means this x and power will reduce, means finally what we are going to get here, this will become log x whole square into x square by 2 and minus here we have log x square and minus 1 by 2 will come outside and integration of x is again x square by 2 x square by 2 and then plus. So this is the answer, but we can write as more simplified form log x whole square and then here we can write x square by 2 and this is log x and here x square minus 1 by 4 x square plus c. So this is the answer of the question number 49. Right, now we'll move to the next question, that is question number 15 what we have given here. So question number 15, let I equal to I is equal to what? So I is equal to here we have given x square integration of x square plus 1 and log x into dx. Right now, how we can integrate it? So we have to decide the first and second function. So this is our first function and this is the second function. Right now here we are going to write the first function as it is outside first as it is log x and integration of the second function that is x square plus 1 into dx minus integration here derivative of the first function that is log x and integration of the second function, that is x square plus 1 into dx into dx. So here this log x will be as it is. Log x is as it is. Here integration of x square will become x cubed by 3 and 1 integration is x minus integration derivative of the log x is 1 by x and integration of x square will be x cubed by 3 and here x and then dx. Now if you multiply this x here, then this, because of this x the power will become 2 and this x will get cancelled out, it will become just 1. Means now here we have in the next step it is the log x and here we have x cubed by 3 plus x and here inside integration what we are getting, so we have just x square by 3 and plus 1 and into dx. So here now we can write it as log x and this is x cubed by 3 plus x minus integration of here. Now finally we are final answer we are going to write, so we don't need to take any bracket or integration sign. So here just one second. Here erasure. We are not going to take anything. So what? Now integration of x square, it will become x cube and 3 was already there, so 3 into 3 9 and then here also it will become minus x and then it is plus c. So this is the answer. Right, now we are going to move on to the next question. What is the next one? So the next question is 16. So 16, let I is equal to what we have given here. So question number 16 is equal to e to the power sin x. This is actually very simple question. e to the power x into sin x plus cos x. Sin x plus cos x and into dx. So here, since we know the rule, which rule? If you have integration, since we know this, if you have e to the power x and inside bracket f of x plus f dash of x, if this type of the combinations are given, then directly we are writing the answer as e to the power x into e to the power x. E to the power x, sorry, this is e to the power x and here we are writing f of x. This is our answer. So here if you observe, this is f of x, this is f of x because their differentiation is present here, f dash of x is present here, cos x. Means answer for these questions will be directly we can write answer will be e to the power x, e to the power x into sin x, e to the power x sin x, and this is the value of what? I. This is our I. Right, now we are going to move on the question number next, that is question number 17. So the question number 17, what we have given here, let I and I is equal to what? So I is equal to integration x e to the power x and this is divided by 1 plus x. This is divided by 1 plus x whole square and dx here only I am writing. This integrand we can rewrite in different form or we can arrange in that form e to the power x into fx plus f dash of x. So I am writing e to the power x here and remaining terms here I am writing x divided by 1 plus x whole square. So what we can do now further? Further we can write e to the power x inside this bracket. Here we can add plus 1, that means plus 1x and same time we need to subtract it also. That means it will become 1 plus x minus x minus 1, and here this will be as it is denominator part. Now what we can do here, this dx will be also as it is. Here I will be equal to I is equal to integration of e to the power x as it is. Here it is 1 plus x divided by 1 plus x square. That means it is just 1 plus x. We are dividing separately both the things, and here it is 1 by 1 plus x square. 1 plus x square whole square. Here we can take this minus with the second terms only, means here we can make it plus, and we can give this minus to this. So this is the minus, means now this is our f of x, and if you derivate it, we are getting f dash of x. This one means answer for this question is e to the power x into 1 by 1 plus x. 1 by 1 plus x, and at last plus c. So this is the answer. Now we'll move to the next question. What is the next question? So the next question is question number 17. Question number 17. Let I is equal to what? I here we have given. So actually I think 17 done. We have to do the question number 18. Now this was 17 already. We did 17. So the question number 18 we have given I integrate e to the power x and then 1 plus sin x divided by 1 plus cos x. And here what? So here dx. Now what we need to do here? We are going to apply that concept e to the power x and fx. For that, actually, what we can do? E to the power x as it is. Here, this 1 we are going to divide by 1 plus cos x. Separately, we are dividing both numerator part. That means, and we can divide here sin x divided by 1 plus cos x. Now, we can see here very clearly if this is our f of x whole square, is there or what? No, nothing. So if you are considering this is f of x, so this will be the, for sure this will be f dash of x, means we can write our answer directly e to the power x into fx, and fx is here 1 by 1 plus cos x. 1 by 1 plus cos x, and here plus c. So this is the answer. Now we are going to move on the question number 19. What is question number 19 here? So let 19, let I is equal to what? So I is equal to integration of e to the power x and then 1 by x, and here we have given minus 1 by x square and then dx. Here also we can write our answer directly, just we need to do one thing. Here we can make it plus, and this minus we can give this to this right here. That means if this is our f of x, so f dash of x is this, right? Second part. That means here also our answer will be directly e to the power x into 1 by x. E to the power x into 1 by x plus c. So this is the answer. Now we'll move to the question number 20. So the question number 20 we have given here 20, let I is equal to what? So I is equal to integration of, I am writing e to the power x first, and x minus 3, and this is divided by x minus 1 whole cube, like this, right? So what we can do here, we can just add and subtract some term to simplify the denominator, means integrate, here dx also will be there. So e to the power x, here I am taking inside bracket, it is x minus 3. So I am writing x minus 1 and then minus 2, here I am writing separately minus 2, like this, right? So from minus 3 we are taking minus 1 and minus 2, means splitting it, and here I will divide this part with x minus 1 whole cube, and here I will divide with x minus 1 whole cube and into dx. So now it is integration of e to the power x, here it will become 1 by x minus 1 whole square, right? And this is 2 by, here we can take plus and here minus, we are writing for the second part only, means 2 by x minus 1 whole cube, right? And bracket close into dx. Now we can see very clearly here that this is our f of x. This is f of x, and their differentiation is this f dash of x. Means answer will be what? Answer will be e to the power x into fx, and fx is here 1 by x minus 1 whole square plus c. So this is the answer of the question number 20. Now we'll move to the question number 21. So the question number 21, we have laid I, and I is equal to what? Integration. Integration is from, not integration of what? So e to the power 2x into sine x. Now which one is the first function and which one is second function? So we know that exponential function is always the last function, and this is the first function. So now we are going to apply the by parts. So if you are applying the by parts here, the first functions, that is sine x, will be outside, and integration of e to the power 2x will be e to the power 2x and divided by 2, minus their integration derivative of the first functions, that is sine b will become the cos x, and e to the power 2x will be here, because this is our I only, right? Here e to the power 2x divided by 2 and into dx. That means now again we need to apply the integration one more time. So sine x and e to the power 2x, and this is divided by 2, minus here 1 by 2 outside, and now we are going to take the integration. So here I am taking inside bracket, this is bracket. So e to the power 12, that means cos x will be as it is, but cos x will be as it is, an integration of e to the power 2x, integration of e to the power 2x divided by 2, right? And minus, inside integration, derivative of the cos will become sine, and minus sine, so it will become plus. So minus sine x and integration e to the power 2x, and here divided by 2 into dx, right? And bracket close. Now here we can see very clearly this part. This part is nothing but the given I only. This is the questions only. That means in place of this, we can write I, and then because of this minus, sign is going to change. Means we can rewrite this as equal to what? We can write it as sine x e to the power 2x divided by 2 minus 1 by 2 into 1 by 2, it will become 1 by 4, and cos x e to the power 2x, and here minus 1 by 2 into 1 by 2, it is 1 by 4, it is 1 by 4 I, 1 by 4 I, and left side already it is I. So we are going to take I, and I plus what? So I plus 1 plus 1 by 4 I, 1 by 4 I, and this is equal to sine x by 2 and e to the power 2x, and minus 1 by 4 cos x e to the power 2x. But what is the addition of this? This will become 5i by 4. This will become 5i by 4, and right side part as it is, sine x e to the power 2x divided by 2 minus 1 by 4 cos x e to the power 2. Now we can write finally I is equal to what? So I will be equal to, I will be equal to 4 by 2. 4 by, sorry, 5, and everything will be as it is here. Sine x e to the power 2x divided by 2 minus cos x e to the power 2x e to the power 2x divided by 4, and plus c. So this is the answer, or further we can just cancel this or let it be as it is. So this is the answer of the question number 21. Now next question number 22. So what is the question number 22? So let I and I is equal to integration sine inverse we have given here. Sine inverse of 2x divided by 1 plus x square into dx. So first we are going to reduce it. How? By assuming x is equal to tan x. X is equal to tan theta. That means if you are, what is the differentiation of this? So dx will be equal to secant square theta. And I will become now I is equal to sine inverse of it is 2 tan theta divided by 1 plus tan square theta, and here it is secant square theta into d theta. Actually here d theta also will come. It is d theta. So this part, this is no, we know that it is nothing but sine 2 theta formula, means it becomes sine integration of, here what I am writing, integration of sine inverse, and here we are getting sine 2 theta, and this is secant square theta into d theta. So this sine and sine inverse will become 2 theta just, and this is secant square theta into d theta. So finally we can take this 2 outside, and theta is the first functions. Integration of the secant theta is tan theta, and minus derivative of theta is 1, and this is again tan theta into d theta. So what we can do here, we can write 2 into theta into tan theta, and here tan theta integration is the log, and it will become here minus will come, minus will make it plus, and log of cos theta plus c, log of cos theta here, and then plus c. So finally we can replace actually cos theta, since we have in triangle, if you see tan theta is equal to x, that means x and this is 1. So cos theta will be equal to under root of 1 plus x square. That means this hypotenuse, so 1 upon this, means we can write in the terms of the x. So it will become I is equal to 2 will be as it is, and in place of the theta we can write tan inverse x, because from here we can write theta is equal to tan inverse x. So it is tan inverse x, and tan theta is equal to x. So x into tan inverse x, and plus log, and cos means we can write cos is equal to 1 upon under root of 1 plus x square, and here plus c, right? We can simplify further, but if you are leaving our answer here also, it is fine. We can write here 2 times of the tan inverse x, and from here 1 by 2, 1 by 2, and 2 this will get cancelled out. So it will become plus log of 1 plus, we are applying the properties of the log here, plus c. So this is the question number 22. Alright. Now second last question, that is 23. So 23, what we have given here, question number 23, let I is equal to e to the power x squared into e to the power x cube into dx. So you can see x cube and x square, both the terms are present here. So directly just assume x cube is equal to t. So 2x square into dx will become dt. That means from here we can say x square into dx is equal to 1 by 2 into dt. That means I will become 1 by 2 time of the x square, means this will become just e to the power t into dt. Means answer is 1 by 2 e to the power t plus c. And what is our t? 1 by 2 e to the power t means x cube. T means x cube, and then plus c. So this is the I. Final answer is this. Now we are going to move on the next question, that is question number 24. So the question number 24, we have given integrates Yes, I'm busy right now. So question number 25. I is equal to integration e to the power x into secant x also is there. Okay, here one second. Here we need to take this secant x. Mm, secant x and then 1 plus tan x into dx. So now what we can do here is again direct e to the power x into fx concept. So here just we can simplify it little bit. We can write e to the power x. Inside that it is secant x and then it will become secant x into tan x. Or we can say tan x into secant x into dx. So if you are considering this is your f of x, so their derivative is this f of x, f dash of x. That means here answer will be e to the power x into f of x. That means secant x. So plus option you can see. So this is the answer. And this is the last question of this exercise. So we have completed the by parts integrations, by parts concept exercise. Thank you.